how large. I'm going to send that to see everyone can see the slide. And Paul, are we recording?
I believe so, Ben.
Okay, great. Michael,
so can I start?
I don't see your video right now. Is it possible you turned off your video?
I hope not, but let's try this one more time.
You mean his face?
Yeah.
Oh, there it is. How's that? Is it better?
I can see your face now, but I lost the slide.
Okay, gonna.
Oh, that looks great. Okay, great.
All right, and okay. Well, I deeply apologize for my inability to get Teams going. And I guess we're all becoming Zoom people in the end. But thank you very much for the opportunity to participate in this important event. And I wanted to talk a little bit about a project that the Energy Environment Lab at the University of Chicago has been doing with the EPA for many years now, maybe 5 years or so, maybe even a little bit longer at this point, which has as its core or its foundation the idea that just as Netflix helps us figure out what movie we want to see next, and just as Amazon somehow amazingly knows that I love those Lemonhead candies, even though I've never ordered them on Amazon, there might be that same kind of what goes on in the background, machine learning and predictive analytics, could be useful as a tool in regulatory analysis. And the application I'm going to talk about, or in regulatory enforcement, and the application I'm going to talk about right now or today is in deciding which are the next facilities that regulators should go to conduct inspection if the desire, given the desire to find people who are violating or are severe violators. And so let me talk about this, but I should just mention from the outset, this is a project of the Energy Environment Lab, and many people have contributed to it. Ludo Gaze has helped with this. Sarah Armstrong is sitting in the EPA and playing a very important role. And of course, I have a terrific co-author for this as well. So the background, I'll just give a little background on the UChicago Energy Environment Lab. Then using predictive analytics to improve RCRA inspection targeting. And so our application is RCRA inspections. And then talk a little bit about opportunities that the results from this have validated, how they can be applied to other settings and other regulatory settings. It's kind of the finding is generic, it's not just about RCRA. So the UChicago Energy Environment Lab, we have, I think that there's just a tremendous opportunity. You think about academics on the one hand, they have all these ideas, and then you have people who are actually doing things in the real world. And sometimes the ideas that are being produced in academia can be useful for the real world, sometimes they're not useful. And what we're deeply committed to is producing new understanding, a frontier understanding of the world that are particularly around environmental challenges, that both helps us understand the world better and is also impactful for the world. And so the way we try to do that is really just 3 steps. The first is to identify promising solutions to environmental challenges. And throughout these 3 steps, our model is to do this hand in hand with policymakers. And so in fact, the project that I'm going to tell you about began with honestly just some brainstorming with EPA senior staff about a challenge that they were facing and then trying to jointly come up with a solution. And so once a promising solution to environmental challenge has been identified, The next step in the process is to actually go out and test it in the real world, because as we all know, the real world is kind of goofy and unpredictable. And even as ideas that sound very, very sound and sensible in practice may not work out exactly the way we had imagined. And so that's why testing it is critical. And then upon finding results, if you find results that are efficacious, the third step in our process is to work to apply those results to scale up improvements in whatever program has been studied or whatever other program or enforcement activity is relevant. So to do that, we draw on several tools. I'm an economist by training, so certainly looking for guidance from economic theory to help design policies, regulations, enforcement strategies that appear, that at least in principle are promising. The second tool in the toolkit is to use cutting edge impact evaluation techniques to determine the causal impact of the program. The randomized controlled trials are one approach, quasi-experimental methods are another. And then the third primary tool, there's some others that we're not mentioning here, is to use machine learning methodology to help regulators best allocate finite resources. And I should mention one promising area that's kind of cross-cutting one here is whether or not, which I'm not going to talk much about today, is whether there are opportunities to use new remote sensing technologies to aid the enforcement process, which I think they're really very exciting, incredible opportunities. We're working in the state of Colorado and the state of California using these new remote sensing technologies. Okay, so the OECA and the U.S. Chicago Energy Environment Lab began our partnership in early 2015. That's true, actually defined somewhat narrowly around this exact project, but in all candor, our conversations with the EPA probably date back to 2013. It's just that it took a little while to find something that everyone was comfortable doing. And what we landed on was to collaborate to develop and evaluate the effectiveness of novel techniques for supporting compliance assurance efforts. And so Sarah Armstrong, who's on this call, Sarah, you might want to say hi.
Hey, everyone.
Yeah, and Sarah, do you want to describe, it might be useful if you describe your role, because I think it's pretty unique and I really has been instrumental, maybe critical is the right word, for making this partnership work.
Mm-hmm. Yeah, happy to. Sarah Armstrong, I've actually been sitting with the EPA at headquarters in Washington since 2017, kind of the first of our embedded research fellows that actually sit in-house with our partner agencies and develop research projects and actually implement the projects and then eventually help scale up those efforts. So I've been working with EPA both on this RCRA machine learning project, new machine learning projects, and then other initiatives across regulatory programs and issue areas. So it's a pretty unique model, and we've expanded with research fellows sitting with other state agencies and developing projects there, but it's very unique in the sense that you're on the ground and basically functioning as the intersection between the practitioner and your academic colleagues and basically synthesizing everybody's thoughts and helping guide the project. And it's, I think, maybe I'm biased, but I think that it's turned out to be pretty effective.
Yeah, and I think, you know, when you contrast it with the alternative, which is, you know, periodic conference calls, you know, there's just so much information and communication that really only occurs through day-to-day interaction. Now, of course, we're in this strange Zoom world or Microsoft Teams world right now, but there's so much information that gets lost if you only depend on occasional check-ins. And so we have found that this role of embedding people, which Sarah was the first in the US, but it's something I've used in research in other parts of the world, that is really critical. And one thing I also want to emphasize that is that a big part of our model is that the government agency should not pay for the embedded person. Rather, we raise resources to do that. And I think that provides a little more independence, which helps, I think, make the projects, it probably improves the lines of communication. Okay, so here are some of the people we've worked with and or are currently working with. The EPA, the State of Colorado Department of Public Health and Environment, California Air Resources Board, and there's other groups up here, including some outside the United States. So let me tell you a little bit about this project that we did. So I don't know how many of you saw Moneyball, but this is like, if you're a data person, this is like the great moment in Moneyball. So that's Brad Pitt, who's playing Billy Bean, who's sitting in the chair, the Oakland A's general manager. You know, he's like the jockey, cool, athletic guy who runs the team. And then that's us standing in the tweed coat and pointing at the board, saying, hey, you can evaluate which players are going to end up being really good. You don't just have to, like, I think in the movie Brad Pitt, or the scouts who work for Brad Pitt were using whether or not the baseball player had a pretty girlfriend or how they walked or something like that. And the nerdy person in the tweed coat there is saying, well, at least in addition, maybe even a replacement, but at least in addition, there's a lot of truth buried in the enormous amounts of data that we have on most baseball prospects. And all this project does is say, hey, when you're trying to decide where to send the next, assign the next inspection, there's no doubt that the people who run the program are going to have inside information that's very useful. But maybe there's some patterns in the data that could be also useful to kind of further refine the decision. And so the advantage of using this predictive analytics approach is that it can discern subtle relationships that are not, you know, as easy to detect as whether or not the baseball player had a pretty girlfriend. You know, this goes by several names: machine learning, artificial intelligence, data science, big data. It's all the same thing, though. It's just using data, and oftentimes regulators have reams and reams of data on historical data that is very well suited for this, using big data to refine the predictions. As I mentioned at the outset, private companies have been using predictive analytics to inform decisions and improve performance for years. Detect, you know, just some examples are detecting potential credit card fraud, product recommendations. And the point I just want to make, and this project makes, is that there's literally no reason besides just, you know, not changing, that this same approach can't be applied to government services or public policy sphere. You know, and there's good examples out there. The New York Fire Department is prioritizing building inspections by predicting which buildings are more likely to catch fire. The Chicago Department of Public Health predicts children at high risk for lead poisoning for screening, since they don't have enough money to conduct screening for all children. Okay, and you know, so it's cool to do cool new things, but I think that's probably not good enough often. And what this is really offering is a greater efficiency. And what do I mean by that? So if a program had a goal of collecting a particular number of violators each year, then of course, if you were more likely to find a violator with a given inspection, then you could save resources and devote them to other high value things by conducting fewer inspections. Or maybe you wanted to find the same number of inspections, same number of violators, and you wouldn't have to increase the number of inspections to do that. You could do it while holding constant number of inspections by using targeting. That's what this offers. So, well, how do you go about doing this? You know, so first I'll just note that there's inspection programs all over government. They're used to protect the environment, the health, people's health, food, worker safety, on and on and on. But a common feature of all of them is that there aren't enough resources to inspect every facility every year, or you know, it might be warranted a couple times a year. And so what we worked out with the EPA was, how can regulators identify more violators with fewer resources? So our proposed solution, which we proposed to the EPA, was, well, let's use, you have all these years and years of data. So Sarah, how many years of data did we have available to us in EPA files that were not being utilized?
15 years worth of historical data.
So basically, we took the 15 years of historical data. Oh, there it is on the slide. And it has just incredibly detailed, rich, detailed histories of the EPA's interactions and the facilities filling in of surveys. It has information on their characteristics, their location, their industry, the result of historical enforcement and compliance actions through the RCRA program, which was the program we were focusing on, as well as other regulatory programs. And so what we did is we used that historical data to predict which places were most likely, when inspected, to have a severe violation. And we did this in the historical record. What we found, let's see if I can move the slide. And what we then found was that we could use that to predict facility risk level in the recent past and compare that to actual violations in 2019. The result, though, of this statistical exercise is that there's a risk score for each facility, which provides the likelihood that if you were to inspect that facility, you would detect a severe RCRA violation. And so just imagine that if you were conducting your inspection program, and of course the people who run the inspection programs are going to have on-the-ground information that's useful, but in addition, you had available information from the model that said, well, you know, here's the probability that you're going to find it. Would that lead to detecting more inspections? These models are pretty complex. I think probably for today it's not that useful to go into it, but here's just a graphical depiction of that. So let me, slides I think are a little bit out of order. Let me just say, going back here, that what we found in the historical data was that our model was able to increase the rate at which, in the historical data, if inspections had gone to the places that the model predicted, as opposed to the places that the inspectors picked, and there was some overlap, we could improve the hit rate by, I think it was 80%. And in the history of this project, what happened was we thought that at that point, once we were able to show that in the historical data, we thought, well, that's great. And now the EPA is going to be super excited to adopt this. And this is where these development of trust and these partnerships is so important. And what the EPA program administrators came back and said is, okay, we see that in historical data, but we think that we have reliable on-the-ground information that's outside that model. We're not so sure that it would actually work in practice. And that's, you know, that was a key moment, and I kind of thought, oh my goodness, our work here might be done, and it didn't work. And then I said, a couple months later, I came back and I said, well, okay, I have an idea. Why don't we run a horse race? Let's prospectively pick a number of, you pick a number of facilities to inspect, and the model will pick a number of facilities to inspect, and let's see who does a better job in practice. And I think the program administrators thought, okay, this is now here we have something that we might be more comfortable with making a reform based on. And so let me tell you a little bit about that field test. So in that field test, what we're doing is exactly what I said. The EPA regions are handing over a list of places that they want to inspect based on the information they have, and then we're letting the model have a list, and then we're running this horse race between them. The way this works is all eligible facilities are get a risk score. Some are chosen to be inspected by the EPA, some are chosen to be inspected by the model. We line those up, and then we're going to randomly sample from both lists and see which list produces more hits or more detections of severe violations. So the results to date are very encouraging. They suggest that the model increases the likelihood of determining a severe violation from about 25 percentage points to 36 percentage points. So that's like almost an increase of 50%. That's a little bit, that's not as good as we did in the historical data where we thought we would improve by 80%. But just to put it in context, like why is this so valuable? If the EPA in fiscal year 17 had been using the model to assign its roughly 1,200 RCRA inspections, they would have been able to find about 140 additional severe violators without increasing inspection resources. And so what we took away from that is it indicates that predictive analytics can substantially improve the efficiency of environmental inspections programs. Sarah, is there something you want to add here before we go to the next section?
Yeah, I would just say, am I echoing? Can you guys hear me?
Yeah.
Okay. I was just going to say, with your comment about how this actually performed lower than how we did on the historical data, I think one thing to consider is, or to keep in mind, states and regions, is that obviously there are different organizational priorities, different criteria that states and regions each have to meet, and if we are staying within those constraints, obviously you're not going to perform as well as if you had reallocated all of the inspection resources to going after the top 2% of facilities by rank of violation risk. So I don't want anybody to think that that's just because the model wasn't performing well. This is just really thinking about the institutional constraints that we face in practice.
Okay.
Michael, we also had a question from the audience that during the last section, they said, how do you know that the past data is representative enough of all relevant cases? What if firms shift their behavior or adapt in a way that past historical data is no longer a good predictive model for the future?
Yeah, so I think what the questioner has in mind, let me take the most extreme version of that question. The most extreme version of that question is, oh, this is so, the firms are so smart, they're going to figure out the assignment rule for the inspections, and they'll make sure never to be inspected, the bad guys, the violators. I think that's the extreme version of the question, which maybe is not exactly the question being asked, but this is where the black box nature, I think, of machine learning actually is a benefit. It is pretty complicated to understand the role of individual historical data in affecting a prediction. Let's see if I can come up with a graphic. And I think it's very, very difficult for the firms to be able to detect it, to be able to figure out the rule. I should also say, like, the algorithm would ideally be rerun every year, and I'm sure those relationships would change over time, and that would be picked up in the algorithm. But it's a good question. But so it turned out, like, two variables that mattered a lot were violated in the last 5 years. That's kind of predictable. But whether or not they had shipped more than 5 tons of waste in the previous year. And so the ways in which they mattered, I think, were too difficult to predict. So I think it's a great question. I think in practice, I don't want to say this is bulletproof, but in practice, I think it's probably not a very large problem. I just wanted to talk before we open it all the way up to questions, a little bit about improving inspection targeting and efficiency in your program. So let me just talk a little bit about how the EPA has absorbed this. So the first thing is the EPA has, based on these results, have rolled out this targeting framework nationwide for RCRA. The second is an EchoGov targeting tool driven by predictive analytics is to be launched this fall. We've then, we're working, I think, to have now delivered a model that supports targeting inspections in the clean water program. Sarah, do you want to just provide a little more color on this slide? In some sense, you know it better than I do.
Yeah, definitely. So with regard to actually delivering the model to the EPA, so we actually spent the last year working with our EPA region partners that actually participated in the field test, as well as ECOS and at SWAMO, and a number of ECOS member states and a work group to get their feedback on interpretability of the model, how to adjust it so that it's more in line with priorities of the states and the regions combined, and have really put together this kind of next generation model.
And Sarah, can you just underscore, this is right now you're talking about RCRA, right?
Yes, talking about RCRA right now. So that output will be available on EchoGov this fall. And then we're also currently working with EPA on another machine learning model that's specifically focused at predicting which facilities that are regulated under the Clean Water Act, so in the NIPUS program, are most likely to have violations determined upon inspection. So we're working with EPA right now to fine tune some of the data cleaning, but we should have our beta model finished this fall and in discussions with EPA on how to actually implement this in practice and what the next steps are.
Yeah, and so let me just underscore. So really what Sarah's saying is the EPA was so taken with this that they rolled it out for RCRA, which is where we tested it for the country and for states and EPA regions, and believe that these results are not specific to RCRA per se, but rather to inspections programs per se. And we have now developed a model for the Clean Water program, Clean Water Act inspection programs, where this approach is being applied. And so this is all meant to say this tool is highly flexible, can be used in a bunch of settings, and is now being used in a bunch of settings. Yeah, so I think maybe that's what this next slide really says. Sarah, is there anything to add here, or I think that's right?
No, I think that covers it. I think we'll probably be reaching back out and doing other webinars in the near future, talking about next steps and how states can get involved with implementing this Clean Water Act machine learning program. But yeah, I think that covers everything.
Okay, so I think what I would just add here is, if you have a program that you think where this might apply, we would be very happy to talk to you and kind of engage in a similar process of going from just brainstorming about ideas on how to more efficiently run the program to turning those ideas, making those ideas concrete, and then testing them, and then, you know, ideally, if the results are advantageous or desirable, talking about how we can support the scaling of them inside your programs. So be happy to talk. I would be happy to talk to anyone. And Olga Rosipashova, who is our executive director, and Sarah's name isn't here, but Sarah's got a lot of expertise here, and she would be a great person to talk to as well. So I just want to say thank you, and I'd be happy to take any questions. And I think now that I've mastered Microsoft Teams, I'm going to stop sharing my screen.
Okay, so we do have a couple questions from the audience, and I encourage other people to 28 compliance monitoring strategy specifies inspection frequencies for only some types of RCRA facilities, LQGs and TNCS. Were you able to include other RCRA facility types in your analysis? And if so, does the model predict that other facility types should be covered in the CMS as well?
Sarah, do you want to take a first stab at that?
Yeah, definitely. So I think there's multiple questions within this one. So I think starting with the most straightforward one in terms of what facility types are actually included in the model. Right now, we only have the model focused on large quantity generators. This is because the field test was primarily being implemented with the regions, and that's more their purview relative to the SQGs. There's definitely been interest from the EPA and states that I've spoken with in expanding the scope of the framework and thinking about applying this to SQGs and other spaces within the RCRA program. And then I think the second part of that question was about the CMS and how this kind of fits in with that. So I'm going to keep it high level because I'm obviously not an EPA employee. I'm not going to speak to their CMS policies, although I know that they're working on a new version of the RCRA CMS. So this is one of those institutional constraints that I was talking about earlier that affected the field test. I do know that they are encouraging use of these types of approaches and this model in particular, but I can't speak to how it's actually going to be represented in the new version of the CMS.
Great. I have another question from Paul Ferraro, one of the organizers of the webinar series. He asked, are you going to test the tool for the Clean Water Act context, or just assume that it will work like the RCRA context?
I think the current plan is just to scale it. We would love to do another test, but it's possible that you know, there's a balancing act between academic interests and policy interests. I don't know, Sarah, do you maybe, what's the latest on that?
Yeah, no, I think that's exactly right, Michael, that, you know, of course, if we could evaluate every new enforcement tool and policy prospectively, obviously we would. But I think that this is something that the EPA is thinking about right now, as Michael said, leaning towards not evaluating this model in particular and moving forward with this machine learning application, but instead thinking about how can we save our research resources, you know, time, effort, and thinking about how we can direct that to the next big question.
Yeah, and let me just add, you know, pivot off that a little bit. What's really interesting is that in our experience with EPA, I think this is, and obviously I don't want to speak for them, and there's EPA, maybe some EPA staff on this call who might want to speak, but this has increased their interest in doing evaluations, maybe not doing another evaluation of inspection targeting. And, you know, we're currently engaged in some different projects with them where there's actual real randomized control trials being implemented. And so I think that's another advantage, and I think that's what Sarah has played a very important role in, is just being around when new ideas come and talking through them and which ones might be good candidates for being successful and also being amenable to evaluation.
I have another question here from, actually an anonymous question. They say, I heard some regional managers say this worked well, and others say it didn't work at all. Where it didn't work, why do you think that was?
Yeah, it's a good question. It is true that there's some variation in the efficacy across regions, but there was, honestly, there weren't enough inspections in each of the regions to really be able to say anything precisely. So I would say in a qualitative sense that's true, but in a statistical sense, we don't know if the evaluations We don't know if this was truly more effective in some regions than others, but in a qualitative sense, it has been.
Another question here from another anonymous question was for RCRA. I have heard that types or number of inspections are highly dependent on the specific inspector. Did your model account for this factor at all?
Yeah, so actually we have, if I remember right, sir, we have the identity inspector, and we even do comparisons where we look at inspector, the likelihood of detection when it's the inspection is chosen by the machine versus when it's chosen by EPA staff. And so we're able to do that. I don't, the results are qualitatively unchanged.
Okay, another one from Mike Barrett says, FYI, we are starting to work on a CWA predictive analytics model now, early stages for general purpose. I guess not a question, but a comment. Do you have anything to say on that?
Yeah, so we tried to cover that. And if Mike is on the phone, has a microphone, I think people would probably benefit from hearing his perspective. He's been a total leader in this enterprise, and we would be nowhere without Mike. It's terrific. So maybe he wants to say something.
I think that we don't have, I think he doesn't have a microphone right now, unfortunately, but I'm sure you appreciate the shout out there.
And Sarah probably, Sarah, do you meet, how frequently do you meet with Mike? Once a week, once every 2 weeks or something?
Yeah, Mike and I have historically met once a week. So just to echo what Mike was saying in his comment, and I think this is important for the states to hear. So right now, one thing that we're trying to do with this Clean Water Act model is specifically look at how much we're able to predict for general permit facilities. So obviously, there's a lot more inspection activity with the individual permitted facilities. So we're really trying to think about how can we shift this to the general permits that don't have as much attention from EPA headquarters at the very least, just because there are just so many more of these facilities. So thinking about how can we get the best bang for our buck. And I know that this is something that's probably of particular interest to the state agencies online.
Next question is Mary Evans asks, is the risk score facility specific or facility and time specific, where the latter would make predictions on which facilities to target and when to conduct an inspection?
Yeah, so we rerun it every year, and so the idea is for it to be refreshed and refined every year so that there would be predictions available for each fiscal year.
Mm-hmm. And then to supplement what Michael is saying, so we actually also have a two-stage model pipeline where we have an initial inspections model. So we're predicting the likelihood also that a facility is going to be inspected in the fiscal year of interest. And then that's used in actually weighting the observations. I think this also gets back to what somebody was saying previously about, how does characteristics changing over time and how it relates to the outcome affect the performance of the model. So I think that response is twofold to both of those points.
I'm going to ask a question that I have myself, which is, I think that it's pretty natural to think that targeting inspections to find violations will also have the consequence of preventing violations. Those two things, finding violations and preventing violations, aren't exactly the same. I was wondering if you have any intuition about how closely those two things are related, and whether the regime that minimizes or that maximizes violations found is also the one that minimizes violations.
Yeah, no, so that's a terrific question. So there is no question that with current resource availability and basically every single inspection program in the United States that I'm aware of and outside the United States as well, that you're never going to be able to conduct enough inspections to catch everybody. And so I don't want to say the primary, but number 1B reason to target violators is to send a message and make other plants concerned that their probability of being caught for violating is high. And so that we call like the threat effect. And that is outside of this study, but there's no question that just that theory says very clearly, and in fact, we would have liked to design a study that would have been able to measure this, but we were not able to for a variety of technical reasons to measure the threat effect. But yes, if everyone understands that the probability of being caught has gone up, it's very natural and straightforward to predict that the probability of violations will go down. And that's obviously not just true in inspections, it's true with these stupid speeding cameras, which the city of Chicago has installed all over the place. And now that after, 6 months of being on a almost, monthly letter from them asking for $100 for speeding, I now no longer speed. So. You're on mute, Ben.
Thank you. I see a clarification from Mary Evans. So Mary asked about both the facility specific and the timing of it, and I think your question was about the frequency with which the model is updated, but the clarification is that she asked because at least for some pollutants there can be important seasonal variations. So I think the question was more specifically when within a year, or does the model say anything about when within a year you would want to inspect a particular facility?
Yeah, Mary, that's a terrific question. We did not take account of that. And maybe that's something that should be done in the future. That's a terrific question. Sarah, we never tried anything like that.
No, but I will say this is something that we've been thinking about with the Clean Water Act model. I've spent just a lot of time looking at the NIFTY's data and am very familiar with the seasonal variation and those violations, and especially the effluent violations. So it's definitely something that's at the top of my mind when thinking about this next model. So it's a great question, though.
I don't see any questions right now, but Catherine Dawes did want to chime in to vouch as acting evaluation officer for your observation about EPA's increased interest in impact evaluation generally. And actually now I do see a comment from Mary Evans, so continuing that conversation, just saying that particularly the timing issue might be important for water.
Yeah. So look, all I can say in response to Catherine Dawes' comment is EPA's just been a terrific partner, really better than we could have hoped for. And we're trying to hold up our end of the bargain, and I think Sarah has been an important piece of that. So having someone there, having someone sitting there, which is central to our model, and sitting there every day pre-COVID is central to our model. Okay. I don't see any questions in the queue, so I think I'll take this opportunity to thank Michael Greenstone again for an interesting presentation and great engagement with the questions afterwards. It was really interesting to hear about your work, and I thank you for being a part of it. Thank you.
Thanks, Michael.
Okay, I think we're gonna close it out then. Maybe someone got it in. Oh, we got another question. You okay with another question, Michael?
Sure.
Okay. So this one is, in terms of investment, how long did it take to develop the model?
Very good question. I think probably the hardest part was putting together the data. And because there were, as Sarah said, there were 15 years of data, and making sure that the variables were defined consistently across years, and that there's just kind of standard data cleaning things. That took a good while, and then of course the development. Once that's done, then you can do the model itself. And I think we now have a pretty good handle on how to make these models go pretty quickly. But so I think the biggest investment was just getting the data all cleaned up and in a usable form. I should have mentioned, yeah, I think, so my co-author, Catherine, too bad my co-author Catherine Meckel's not here. I think she would have maybe something to add to that about which part was more time consuming, but I'm pretty sure she would agree that the data cleaning was a more time consuming part.
Yes, I will add, just if anybody's familiar with doing machine learning work, about 80% plus of the work is always going to be data cleaning, but well worth it in the end.
I see a comment here from Randy Hill just complimenting Sarah. So great way to collaborate, being able to work with Sarah live. And there's another question. If regions / states are interested in giving input for NIPSEs, how do they get involved in the process of building it and testing it?
I would probably defer to my EPA friends. You know, I think what the proper way to do that is, but we're always looking for input and guidance. I mean, you guys are the people who run the programs. We just have the data. So I think our data analysis can only be improved by better understanding what's going on the ground.
Yeah, and I think there's two different points to this, right? There's the development of the model and then actually thinking about how to implement it in the field. Like Michael said, in terms of implementing in the field, I think those are going to be ongoing conversations with the EPA throughout the fall and the states, obviously. But in terms of actually developing the model, I'd be very happy to chat with anybody, any feedback that folks would like to give. I'm always happy to hop on the phone and talk through that. So please feel free to reach out to me. I'd love to chat with anybody who has thoughts.
I see a comment from Randy Hill, which says they should contact Mike Barrett. So I think that's specifically about the interest in NIPSEs. Okay. Yeah, Mike Barrett says, for NIPSEs, we will look to replicate our state collaboration we did with RCRA. I think that's on the same topic. Mm-hmm. All right. Well, I think that's going to bring us to a close. Thanks, Michael, and also thanks, Sarah. Sarah, you were a huge part of this presentation, so don't want to forget that. And everyone at the Chicago Lab, and all the participants for asking questions, and I hope to see you at the next webinar. Thanks, everybody.
Bye-bye. Take care.